Ready. So good evening all of you. So the summary of the last lecture we have discussed this classification of the particles. Now today's class is very crucial, listen carefully. Take the fresh page and put the heading conservation laws. If you are not learning this, get ready to lose 5 marks. Take the fresh page and put the heading conservation laws. Conservation laws. It's very important. Right. So what are these conservation laws? Generally in mechanics, if you see what are the conservation laws, conservation of charge, conservation of mass, conservation of energy, conservation of linear momentum, conservation of angular momentum. Apart from all these things, that means earlier we have seen conservation of energy in mechanics and momentum, of course linear and angular momentum, and the next one is a charge. All these things we know. Apart from this, in particle reactions, we are going to discuss some more conservation laws. First one, Lepton number, which is represented by capital L. Next, second one, Baryon number, which is represented by B. Next, isospin, which is represented by I. This was introduced by Heisenberg. Isospin, similar to spin, isospin. Okay, it was introduced by Heisenberg. Next, fifth one, third component of isospin. Third component of isospin. Generally they call it as a Z component also. Your wish, you can say either Z or I3. And the one and only dangerous last one, that is strangeness quantum number, or simply strangeness, which is represented by S. So these are the conservation laws we are going to discuss in this particle reactions, apart from the charge, energy, momentum. Sir, how we will check energy? By using mass. Initial mass before the reaction, after the mass after the mass after the reaction. Linear momentum I will discuss later, angular momentum also I will discuss later. Charge, by simply seeing that means you have to add that powers on left side is equal to that powers on right side. That powers indicates what? Charge. Clear ma? And linear momentum, angular momentum I will discuss later. And this one it's not possible to discuss. The reason is you have to remember lot of so many particles masses, or at least you have to know which is heavier mass and which is a lighter mass. What the common sense is, lighter mass particle never give you heavier mass particle. That's why a lepton never gives baryon, but a baryon gives lepton. I hope you got the point. So I told you already, leptons lighter mass, mesons medium mass, baryons heavier mass. Just remember that. Okay. Now let us start one by one. Very important, please focus. First one, lepton number, which is represented by L. So how to define this lepton number? The lepton number is defined as either +1 or -1 or 0. What is the lepton number? +1, -1, 0. +1 for leptons, +1 for leptons, -1 for anti-leptons, anti-leptons, +1, 0. Others. Now I told you already elementary particles, one is leptons and hadrons. Hadrons are classified into mesons and baryons. So that's why basically you have three groups: leptons, mesons, baryons. Once again, leptons, mesons, baryons. Other than leptons, other than leptons, that's it. That means 0 for mesons, 0 for mesons and baryons. So if I have a baryon, its lepton number 0. If I have a meson, lepton number 0. Lepton number exists only for leptons and anti-leptons. What are other particles? Mesons and baryons. If I say proton, its lepton number 0. That's good. Okay, now wait a minute. Some textbooks are doing the wrong thing. They are treating electron family, mu family, tau family as a single L, which is wrong. Remember one thing: if a family member is there, another, what I want to say is the same family, either particle or antiparticle, must exist. For me means, if you have an electron one side, other side or this side, you must have same electron family or antiparticle family. For example, this side electron is there, that side mu is there. Some textbooks or some materials or idiots are writing simply L is equal to this side electron 1, that side mu 1, both are conserved, lepton number is conserved. Absolutely wrong. One more time I am saying, lepton number you should not check overall for leptons. You have to check separately for electron family, mu family, tau family. Very important. So while you are checking the lepton number, you have to check, I hope you understand what I am saying. This side you have electron, that side you have mu minus. So you should not write lepton L is equal to +1 here, both are conserved. No. You have to check separately for electron family, mu family, tau family. That's most important. Le. For electron family, for mu family, for tau family, L tau. Now see, again electron family, one is the particle group E minus and nu E. What are particle group? E minus and nu E. For E minus and nu E, it is a +1 or -1? +1. Good. Corresponding antiparticle group E plus nu E bar. For this Le, it's not simply L, it is what? Le. Next L mu. L mu exists for mu family. Mu family, mu minus, nu mu. Antiparticles. Now, what is L mu for this? L mu for this? L mu for this? That's good, that's good. Again, for tau, you have again particle as well as antiparticle. Tau particles. Babu, seems to be easy and you think that you understood. But whenever you are answering the question, definitely there will be confusion. Be careful. Antiparticles, tau plus nu tau bar. So here L tau, here L tau, here L tau. So this is the story of leptons. While you are checking leptons, one more time I am requesting you, don't follow some books are given like this, some materials are given like this. Please throw away those things. You have to check separately for electron family, mu family, tau family. So what I am saying is, if one family member is there in the reaction, definitely same family or antiparticle family must be there. For example, in a reaction, E minus is there. You must have E plus, nu E or nu E bar. If a mu minus is there, for example, mu minus is there, in that reaction there is no other particle from mu family, reaction is forbidden. No need to check at all. If an electron is there and there is no, are you listening? Yes, if an electron is there and there is no other particle in the reaction from this group, then it is forbidden. Please remember this. So we have to check the lepton number separately for electron family. So wait. And the next important thing, you know what are leptons already. What are leptons? Leptons means particles. E minus nu E, mu minus nu, tau minus nu tau. These are all particles. What are corresponding antiparticles? E plus nu E bar, mu plus nu E bar, tau plus nu tau bar. I will give you one small suggestion. For leptons, if a negative sign is there, it's a particle or antiparticle? Negative sign, positive sign, what is this? What is this? If a bar is there, bar is not there. No bar. Bar. Sir, why you are saying like this? Because while you are answering the question in the exam, all the things will be mixed up. That's why you have to remember like this. It's a better way. Whenever you are dealing with the leptons, how to identify whether it is a particle or antiparticle? Plus, minus, bar, anti to bar, anti bar. అర్థం కాలేదు మీకు, రైట్. బార్ యాంటీయా నాట్ యాంటీయా? యాంటీ. ఇప్పుడు అర్థమైంది, రెడీ. అంటే బార్ యాంటీ, ఓకే. అది నో బార్ ప్లస్ minus. Are you ready? Now I will say the particle, you say it's a value. Ready? If I give particle, you have to say +1. If I give antiparticle, you have to give minus. If I give another particle which is a not lepton, 0. Now you are going to say the lepton number. Ready? One more time. How to identify leptons, particle and antiparticle? Negative sign, particle. Positive sign, antiparticle. Opposite. Negative sign is there, value is +1. Positive sign is there, value is -1. Bar is there, minus. No bar, plus. If other than leptons, any particle is there, 0. Ready? Nu E, and just say +1 or -1. Ready? If I say bar, if I didn't say bar, if I say plus, if I say minus, ready, start, ready? E plus, nu E, nu mu bar, tau minus, తగ్గారు, సౌండ్ తగ్గింది, +1. రెడీ? nu tau. See, if you try, then only you will get it. Do you think it's an easy task to answer in the question? All the values will be circulating here. That's why you have to practice. Nu tau, E minus, nu E bar, mu plus, nu mu bar, nu E, nu tau, tau minus. ఎందుకు ఆ టౌ దగ్గరే పోతున్నారు? దుంపలే కదా, నోబెల్ ప్రైజ్ వస్తే దానికి. టౌ మైనస్ ఇప్పుడు ఈ మైనస్ +1, మ్యూ మైనస్ +1, టౌ మైనస్ ఏం పాపం చేసింది? గర్ల్స్ కరెక్ట్గా చెప్తున్నారు. రెడీ. సో ప్రోటాన్ E minus new bar okay new E bar new mu bar anything. That's it. So like that you have to remember, amma. So other than any leptons, what are these lepton number? 0. What are other particles, ma? Mesons and baryon. Whenever you have meson and baryon, lepton number is equal to 0. And leptons, if a sign is a negative, +1. If a sign is a positive, minus. Bar is there, minus. No bar, come on, start. Sorry. Lepton number. We have to check separately for each family separately. Electron family Le, mu family L mu, tau family L tau. For particles it is a +1, antiparticles -1, others 0. How to identify particle or antiparticle? Plus is there, antiparticle, minus is there, particle, bar is there, antiparticle, no bar, particle. So one more time I am saying, either family or anti-family, if one particle came, definitely there must be another particle from that family, either from family or anti-group or group. This is a group and this is anti-group. If one particle is there, another particle must be there, otherwise reaction is forbidden. Don't copy the particles, write yourself. It's okay. It's actually 8391, I think. 10 to the power of 9, whether it is 81 or 83, nothing will happen. Once again everybody say leptons. How to write the lepton number? For leptons, there is a negative sign, plus 1 or minus 1. There is a plus positive sign, there is no bar, there is a bar, there is a bar, negative sign, positive sign, bar. Now ready. Now let me explain one, and one more also I will explain. After that you just do 2-3 questions. All of you please listen. Stop. Now this is the reaction, and we are going to check the lepton number. Everybody must write like this. Only this notation only how to follow. All of you please. L for lepton number. Now see, whenever you are seeing a particle, question yourself, is it a lepton? What it is? That's what you have to get. That's why I told you yesterday, reverse you have to learn, reverse you have to learn. Neutron, baryon. Is it a lepton? No. 0. Proton, is it a lepton? No. Wait. It's a lepton. Yes. Particle, antiparticle. That's why. Is it a lepton? Yes. Particle, antiparticle. Minus 1. But whenever you are checking lepton number, which family exists? That's why you must write Le. Some books will write L and they will count all the particles as a mu minus, E minus, tau minus, everything is a lepton. Wrong. One more time I am saying wrong. Old theory they have done like that. Maybe some old they have copied from the old book. That's why they are writing. But it's absolutely wrong. Always you have to follow Le. Clear? One more. I am taking a mu minus gives E minus plus nu E plus nu mu, something like this. Okay, all of you please listen. Just like this I have taken. Now see, while you are checking the lepton number, question yourself, which family is there? Electron family is there? Is it an electron family? No. Is it electron family? Yes. Plus or minus? Yes. Super. Is it electron family? Yes. Answer? Minus 1. Is it electron family? No. No. Oh, this side how much? 0. And this side also add. How much? 0. This side 0, this side 0. That's why it is that is conserved or not conserved? Put a right mark. If it is not conserved, right. Now check. Left side, 0. Right side, 0. I hope everybody know how to add. Plus 1 minus 1 plus 0. 0. Okay. Yes, right. Next you have to check L mu. Now, is it a mu family? Yes, particle, antiparticle? Is it a mu family? Is it a mu family? Is it a mu family? Particle, antiparticle? Left side, right side. Okay or not okay? Not okay, just cross. This is what you have to do. Ready? Yeah? Ready, start. Separately check for each family. you have to check lepton family, electron family as well as mu family, both are there. Now, ready, over. So, it is a pi plus, you are checking Le, is it a lepton? No. Is it a electron family? No. Now, electron family, plus 1 or minus 1 or? Plus 1. This is particle anti, this side is 0, this side is 0, okay. Yes. L mu, still if anybody not understand, just question yourself, is it a lepton? No. Next, it's a lepton, mu family, particular, anti-particular. Next, electron. So what is the L mu? 0. What is L mu? This side. This side. Okay or not okay? Right. Next, here you are checking L mu. Is it a lepton? What it is? Very good. 0. It's a mu. Particle or anti-particle? How do you know it's a particle? Good. Plus 1 or minus 1? Very good. It's a particle or anti-particle? What shall I write? Anti-particle? Okay, well, if it is nu E, what shall I write? Why? You are checking mu, but it is electron family. Be careful. Don't see here also. Here also you have to see. Okay. Here only don't see. Here also mu. Now it's a particle or anti-particle. What shall I write? Minus 1. This side. This side. Okay or not okay? Okay. Sit down. What I have to check? Le. Is it a lepton? Sit down. This is what I said. Please check carefully. If one family member is there, definitely you must have one more family member. And a family member cannot come outside as a alone, single. Okay? Another family member also must come. Either anti-group or group. That's good. Now, for example, okay, leave it. That we'll see later. Ready? I think lepton number is over. Are you ready? Yes, sir. Next one. So, what is this lepton number? Lepton number. For particles, it is a plus 1. Anti-particles, minus 1. Other particles. 0. What are other particles? Good. How to identify it's a particle or anti-particle in case of leptons? Plus sign. Negative sign. Bar. No bar. That's good. Now ready. Second one. Baryon number. Wait, listen. Baryon number is represented by B. This is also defined as either plus 1 or minus 1 or 0. Plus 1 for baryons, minus 1 for anti-baryons, and 0 for others. Baryon number is 0 for others. Other than baryons, what you have? Good, very good. So if you have a lepton, its baryon number 0. If you have a meson, its baryon number 0. For example, eta naught 0. Sometimes your eyes will cheat. They will write eta and you think it as a neutron and you will write, understand, be careful, check carefully. Good. Okay, so what are baryons we have? Spin half baryons. Spin half baryons. Okay. What are spin half baryons? Spin half baryons. Sit down. Next, spin 3 by 2. Spin 3 by 2 baryons. Spin 3 by 2 baryons.
Delta plus plus, delta plus, delta 0, delta minus, sigma plus star, sigma 0 star, sigma minus star, cascade 0 star, cascade minus star, omega minus.
Omega minus. Kucho. Sit down. Right. So these are all baryons. For all these things, baryon number B equal to. For all these things, baryon number B equal to. Then what are anti-baryons? Here anti-baryons are not there. Anti-baryons contains a bar. Anti-baryons contains bar. If a bar is there on the baryon, what is the baryon number? -1. Now tell me, is it a baryon? Yes, sir. Answer. Yes, baryon? Yes, sir. Baryon? No. Baryon? No. Any baryon here? No. Any baryon here? No. Any baryon here? No. Here? Yes, sir. Here? Yes, sir. One more thing you have to write here. Lepton number. Which addition? Lepton number. Which addition? Scalar addition. Because you have taken a numbers and add. Baryon number is also which addition? Scalar. What is other than scalar addition? Vector addition. Slowly learn. Don't copy the particles, write the particles yourself one more time. That's just like a practice. I think I need not to say example for baryon numbers because it's a straightforward. You have to, you know what are baryons. For those baryons only we will write +1, and other than baryons means you have mesons and leptons. Be careful, you will get a small confusion with the mesons and baryons. Be careful. Lepton number and baryon number both are scalar addition only, no issue, just addition only, that's numbers addition. And one more time I am saying, some people will get confusion with baryons and mesons. Be careful please, because the 3 group, 2 group is there, that's why be careful. What are mesons? Mesons are not baryons, mesons are hadrons. What are mesons? Pi meson, K meson, eta meson, say. small confusion will be there, be careful. I am not giving any example for baryons, everybody comfortable. What are baryons, everybody know. Right. And how to identify whether it is an anti-baryon or not? Bar. For example, P bar is there, N bar is there, then what is the baryon number? -1. Now tell me, what is the baryon number for, what is the baryon number of a quark? Baryon number for proton? +1. What is the baryon number for quark? What is the baryon number of proton? +1. Then what is the baryon number for quark? So good. 1/3. Why 1/3? 3 quarks are there. 3 quarks are there. UD, something like that. So 3 quarks together you are getting a baryon number 1 means baryon number of each quark is 1/3. That's good. Now the dangerous one. Third one. Isospin. Now here onwards be careful. That is a straightforward, but here onwards be careful please. Isospin. Isospin is represented by I. Now let us see. Right. Isospin. Now forget about this isospin. Let us talk about the spin first. Now I am taking electron. So electron spin. Shall I take it as 1/2? For electron. Okay, I have an electron and this is my reference axis, let us say Z axis. According to Stern-Gerlach experiment, if I apply the magnetic field along a Z axis, the electron may be oriented either parallel or anti-parallel. That means you will be having either this orientation or this orientation. That means like this. That means like this. So this is plus half and this is minus half. This is S bar. So your S bar is having two projections along Z axis. One is and these values we call it as MS. Projection of S along Z axis, what we call MS. I hope you know S is equal to half, then MS take values from, say yes or no? Yes, that means MS takes values from where to where? Minus S2 plus S, but total number of values. The total number of values. How many here? S is how much? Then number of values is given by? Always remember, if anything you are having from minus S2 plus S, how many values? 2S plus 1. Minus L2 plus L. Minus J2 plus J. Minus I2 plus I. I ante nenu kaadu. That I. Good. Now this we know. Now let's come to the isospin. Similar to this spin, we have this isospin character. And the most important thing, isospin, very important, exist only for hadrons, only for hadrons. Other than hadrons, what are the particles? What are elementary particles? Hadrons. What are hadrons? Hadrons, classification, name. Hadrons are classified into what? Now, once you, while you are standing, you are going to say mesons, right? That letter enough I can catch, okay? So be careful, sit down. So exist only for hadrons. Means other than hadrons, what you are having? Lepton. So for leptons, not exist. For leptons. Ma, be careful, be careful. Okay, fine. So this is also same. This is the reference z-axis and this is the isospin vector. I hope now you understand. It is a vector. Okay. So this is also having some projections, Babu. Okay. Just like this, just like this. So this is also having projections, and now, okay, that projections are called nothing but IZ. Ikkademo SZ antam. What are these values, ma? SZ. Here what we call it as IZ. That I will come later. Now today we are focusing on what? I. Okay, cool. Wait a minute. So one more time. I exist only for hadrons, not for. So cool. Now how to get this isospin? Actually, I told you already. These hadrons are simply groups actually. Whatever the bracket I have written, as yesterday I told you while you are writing the bracket, you should not remove the bracket, you must keep the bracket. The bracket indicates what? A group. Now, first I am taking one hadron group. Let us take a proton and a neutron. Everybody see. How many particles are there? 2 particles. Actually, hadrons groups are different projections of, that means this hadron group. Each hadron group is the different projections of same entity. Proton and neutron are different projections of same entity. Next one, sigma plus, sigma naught, sigma minus. Different projections of same entity. That same entity is having same isospin. That's why these both are having same isospin. But projection is different for proton and neutron. That will come later. So that's why here we have to introduce one thing called multiplicity. Amma, careful, careful, careful. Nothing but multiplicity is nothing but number of particles in the group. Number of particles in the group. How many? 2. So multiplicity formula equal to 2i plus 1. 2i plus 1. Multiplicity, spin multiplicity 2s plus 1. L multiplicity 2l plus 1. J multiplicity 2j plus 1. I multiplicity 2i plus 1. I told you one more time. That entire group represent a same entity, but different projections. That's why I is same for group. Clear? How many here? 2. Equal to 2i plus 1. Bring this one this side. 2i equal to 1. That implies, could you please tell me what is the isospin for this? Isospin for proton neutron group? 1/2. Wait. Next one. I am taking single group. Eta naught. Eta naught is a lepton or meson or baryon? Is it a hadron? No, no. Now, formula m equal to 2i plus 1. How many are there? Come on. 2i equal to. Then what is the isospin for eta naught? 0. Wait. Don't write ma. Next I am taking 3 group. 2 group I have taken, 1 group I have taken, 3 group. Anything you say. Sigma na? Sigma plus, sigma naught, sigma minus. How many are there? M equal to 2i plus 1. 3 equal to, bring one this side. 2i equal to, I equal to, wait. How many are in the group? Isospin. How many in the group? Isospin. How many in the group? Isospin. Next, I think you have one more group called 4 group. How many? What is the isospin for delta group? Wait. If you see the classification of hadrons, mesons, baryons. If you see carefully, you have groups. Single particle group, 2 particle group, 3 particle group, 4 particle group. Other than this, any group is there? Are you ready now? That's why yesterday I told you bracket is very crucial. So that bracket indicates that will decide the isospin number. Are you ready? Single particle group I, 2 particles, 3 particles, 4 particles. Em ledamma, 4 particles, decrease 1 by 2, 2 particles, decrease 1 by 2, 1 particle, decrease 1 by 2, 3 particles, decrease 1 by 2. Ready? So now I will write the particle, you please tell me it's I. That means by seeing the particle, you have to connect to the bracket, how many are there, and you have to say isospin. Are you ready? See, the particle anti-particle నీకెందుకు అక్క? Why? అది particle anti-particle కాదు కానీ నేను ఏం చెప్పాను, what I told you, how many are in the group. See, మీరు అనుకున్నంత ఈజీ ఏం కాదు అది, ఎంత not that much easy. You have to do lot of practice. Everybody know, if I ask you to write the particles, you will write. But see, reverse you are not able to say. So, by seeing the particle, you have to remember how many are there in the group. K plus, what is the K plus group? K plus K naught. Next group, K minus K naught bar. That's why the bracket is very important. Pi plus, pi naught, pi minus. Eta naught single. Ready? One more trial. How many are there? Decrease 1 by 2. Please practice, because there will be a particle and you have to write like this only. Next, K minus. Next, pi plus. Proton. Lambda naught. Eta naught. Omega minus. Delta naught. Right. Sigma plus star. Sigma plus star group contains how many? 3. What is isospin? 1. Cascade not star. Neutron. K minus. Pi naught. 1 ball 1 ante. K minus. Electron. Good. Next, K minus, K naught, pi plus, pi, doubt చెప్తున్నారు, pi minus, K plus, neutron, cascade naught, sigma naught, 1. Careful. Wait. 1 minute. How to remember this isospin? Amma, single particle group. Wait a minute. Amma, listen. Group. How many are there in the group? 1. So what is the isospin? 2 are there. 3 are there. 1. 4 are there. That's good. Come on, very good. And which addition? Isospin follows which addition? Vector addition. It's a vector. Practice cheyandi, please practice, don't neglect. 5 marks is not an easy task.
Electron is also having isospin 0, it is meson, it is lepton. So, but here isospin exists only for hadrons, but E0 is having I equal to
0 means value, that electron means not exist, that is also 0. Not exist means if a reaction contains electron, what you will write as a spin, you have to write 0 only, not exist. But here its value is 0. For hadrons its a value 0. For leptons it's not exist, that is why we are taking 0, because we are adding, that is why you have to take 0. Otherwise you have to leave that blank. If electron is there, leave that blank. Okay? What is the meaning of blank? 0 only, na? In addition. If one particle is in the group, what is the isospin? 2 particles, 4 particles, 2 particles, 3 particles. Just number of particles minus 1 by 2, number of particles minus 1 by 2. Here little bit careful. Isospin conservation, it is not a scalar addition. What it is? A vector addition. All of you please listen. How to add 2 vectors. Now for example, we have, this is the z axis. Let us suppose there are 2 electrons are there. Everyone please see the board. 2 electrons are there. The first electron spin is S1 bar and the next electron spin is S2 bar. and these two electrons are interacting through spin-spin interaction. Adi LL interaction, SS interaction, LS interaction, like that. Now who are interacting? S, S. Interaction means, always remember, precision. Whenever you want to interact with someone, what you will do? Right, precesses. If you precesses like this, what you will get? Resultant, result. S bar equal to S1 bar plus S2 bar. Don't get tension. Parallelogram law of vectors. The two vectors are represented by the sides of a parallelogram and the resultant is represented by the diagonal. That straight line is the diagonal and these two are the sides of the parallelogram. Understand? Yes. That's it. That is the Bhayankaramaina formula. Triangle law of addition of vectors. Okay. And you understand there is some angle between them. That's why whenever you are finding the resultant values, that means S values, whenever you are adding two vectors, the resultant values always lie in between -2 plus. The reason is, minimum value you will get for 180 degrees, maximum value you will get for 0. If you put 0, you will get a plus. If you put 180, you will get a minus. Are you understanding? So that's why it always takes minimum to maximum. Come on, say. But the resultant quantum number, it should not be a negative. That's why magnitude gaadakai modulus. Modulus is different, magnitude, modulus. So although you are getting a negative, you have to take a plus. So the same thing, the same way. This is my reference axis. I have two particles here with I1 and this is my I2 and these are interacting with each other, two particles, two hadrons. Then could you please tell me what is the resultant I bar equal to? Could you please tell me what are the I values then? I1 minus I2 2. Now wait a minute. For example, I have proton and a neutron are interacting. Let us suppose. Proton and a neutron. What is the I value of a proton and what is the I value of a neutron? Both are having 1 by 2. That's why 1 by 2 minus 1 by 2. Understand? Okay. Proton I, neutron I. Then resultant I equal to easy amma, easy. Answer. Let me take one equation. 1 minute. At a time 3 అంటే మీరు కన్ఫ్యూజ్ అవుతారు, మీకు అంత కష్టంగా వద్దులే. Now ready. I have taken this. Now I am going to check isospin. While you are checking isospin, little bit careful because this is the vector addition which will take negative values to positive values. That means difference to sum. Right. Amma, here is the first particle and this is the second particle. What is the I for this? What is the I for this? Please write like this. I. Now, ready? Still some people not ready. So, isospin. Just subtract, add, subtract. ఇంక మీకు దెబ్బలు పడతాయి. 1 by 2 minus 1 0 నా. Add. Very few people are saying, Ayya, say the answers. What are the left hand side values? Right hand side values? At least one number must be common. If there is no at least one number common, then isospin is not conserved. Understand? One more time. One more time I am asking. If a single particle is there, isospin, 2 particles, 3 particles, 4 particles, ready, say sigma plus 1. Cascade naught, omega minus, lambda naught, pi plus, very slow, pi plus, k plus, k naught, eta naught, lambda naught, proton, sigma plus, cascade naught, k plus, k naught, eta naught, proton, neutron, k minus, omega minus, 1, 0. Ready. Now again isospin. My advice, please write what is the I value. What is the I value? What is the I value? Particle and anti-particle group must have same isospin, because how many are there is important, whether particle or not, anti-particle not important. So only one, 0. Add, subtract, add, any common. Got it? One more. Huh? Say sorry. Say slow. Oh, she's saying loudly, ah. ఇక్కడ ఎవరికి ఎమోషన్స్ ఏం లేవు, అన్ని ప్రమోషన్స్. చూడండి. Ready. So now we are going to check isospin. First write the value. Isospin. Super. I think now you are slowly getting up. See, you are thinking differentiation is better than this, Raswami. Because there is a particle, you have to connect which group, how many are there, and you have to get I. Clear? How many things we have to remember? Isospin. Difference. Sum. Wait. Whenever 3 are there, you can't add 3 at a time. First add any 2. Any 2 you can add. Come on, subtract. 1/2. Sum. Ready? Next. Difference. Sum. Difference. 3/2 minus 1/2. Sum. Any common? Clear? And the last and final statement. Amma. See, K plus and K naught. Particle or anti-particle? K minus and K naught bar. Particle group or anti-particle? Here also isospin 1/2. Here also isospin. So finally what is the conclusion? Particle and anti-particles are having same isospin. Particle group and its anti-particle group have same isospin. See, a differential equation or integration or we will say one formula and we will leave it to you, and if you didn't learn we will scold you. But here it's not like that. You have to remember lot of things. Okay, if you are solving one reaction, mean you are solving the entire particle physics, because total particle physics knowledge you must have to solve that equation, otherwise it's not possible. Come on. vector addition. Be careful, I explained already what is the vector addition. So difference to sum, it takes values from difference to sum. The two more are there, get ready. In your childhood, in the school, at the end of this last hour, you remember what you have done? In the school, second class, third class, first class, you didn't remember. One student will come and he used to say something, and the same thing will be repeated by the children. In your generation, it is not there. Huh? Then something will be repeated. Generally, we repeat poems, so all these names, month names, so like that we will keep on repeat. Oh, you the corporate schools, Ivanni. Oh, IIT JEE Foundation from LKG. Ah, I understood. Come on. LKG onwards foundation. అందుకే బాగుంది ఫౌండేషన్. If I am in the second class, my name is in the first class. If I am in the fifth class, my name is in the fourth class. ఫోర్త్ క్లాస్లో అటెండెన్స్ జరుగుతూ ఉంటుంది. రాజరా అరే వాడు వచ్చాడో లేదు చూడరంట ఫిఫ్త్ క్లాస్లో అంటారా, నేనేమో అక్కడ ఫిఫ్త్ క్లాస్లో ఉంటా. Means in one class itself I studied the two classes, then they send me to the other class. Why you are staying here? అందుకనే ఇప్పుడు వెనక్కి వచ్చా. And finally what happened, I studied 5th class 2 times. Why? When I was actually studying 4th class, I was in 5th class. Again they can't promote to 6th class na. No, this is not possible. So I have to study 5th class again. నేను ఒక్కనే అనుకుంటా 5th class 2 times చదివింది. Come on. Careful about the vector addition. Amma, no need to match all the numbers. Left side and right side, at least one number is common. Please write there. Today practice all these quantum numbers. Tomorrow you will have assignment, 2 assignments on this. Don't copy. Ready? Right. The next one. All of you stop. One more time, please remember what is the statement I made. Hadron group, each group, different projections of same entity. That's why I is same for all those things, but IZ is different because projection means what? IZ. Everyone, please. I hope you know spin of electron is a half, then Sz takes values from minus S2 plus S. Say yes or no? Sz and ms h cross. I am not taking h cross, just I am taking ms. Understand? Right. So minus S means what ma? Minus half to plus half. But always the total number is always equal to 2s plus 1. How many it will take? And these are called number of projections. Now quite similar to this. See, first I am explaining about the spin, then I am coming to the IZ. More important. Now here you have I value, something, I don't know. It may be 0, it may be 1, it may be 2, it may be 3. 2 ledule. 0, 1, 1 by 2, 3 by 2. Like something is there. Then similarly IZ also takes values from minus I2 plus I. Clear? And total number of values 2s plus 1. Here total number of values. This 2i plus 1 is the total number of values which is equal to total number of particles in the group. Understand? Right. So IZ takes values from where to where? Minus I2 plus I. Example. I have taken 0. Could you please tell me what is IZ? Very few people are saying. If I take I equal to 1, then what are IZ values? Super. If I take isospin I equal to 1 by 2, then IZ equal to? Always quantum number is increased by 1 unit. Understand? You should not increase any other quantum number, increased by 1 unit, everything. Next, if I is equal to 3 by 2, if I equal to 3 by 2, very few people are saying, addition a plus 1 plus 1 plus 1. If I equal to 3 by 2, IZ? Now I am taking 4 particle group. Everybody please listen. Delta double plus, delta plus, delta naught, delta minus. I am not giving any formula for this, leave it. Now everybody know this how many particles are there in the group? 4. That's why isospin I value how much? 3. Then I3 takes values from ready? Yeah? So total how many values are there? 4. That 4 values taken by these 4 particles. Which one will take which value? Wait. Higher the charge, higher I3 value. I3 ante IZ. Higher the charge, higher I3 value. That means the particle with the higher charge takes a higher I3 value. The particle with lower charge will take a lower I3 value. Ready? Yeah? Now ready. Now in this group, which is the higher charge? That's why what is I3? Next to lower charge I3 decrease. Next to lower charge I3. Next to lower charge I3. Now you will say here, but once it is in the reaction, you have to remember this belongs to which group, how many are there, what is the charge, these many things. Higher the charge, higher the I3 value. Higher charge takes higher IZ. Lower charge takes lower IZ value. Now wait, how many of you understand this? Second one, I am taking proton neutron. How many are there? That's why I is equal to, ready, which is the higher charge? That's why it's I3 equal to, this I3 equal to, wait, next I am taking K plus K naught. Ready? Yeah? Right. Could you please tell me what is the I for this? What is the I for this? That's why, which is the higher charge? That's why I3 equal to, next. Ready? Yeah? Careful, careful. What is the rule? Higher charge takes. Now, how many are there in the group? How many are there in the group? What is the I value? Now, which is higher charge? K naught bar is higher charge. Why? ఇక ఇది హయ్యర్ ఛార్జ్ లోవర్ ఛార్జ్ కూడా తెలియకపోతే మీకు దండం. వాట్ ఈస్ ద ఛార్జ్? వాట్ ఈస్ ద ఛార్జ్? విచ్ ఈజ్ లోవర్? అందుకే మనకు నెగిటివ్ మార్కింగ్స్ వస్తున్నాయి. రైట్. విచ్ ఈజ్ ద హయ్యర్ ఛార్జ్? విచ్ ఈజ్ ద లోవర్ ఛార్జ్? వెరీ అండర్స్టాండ్. నౌ వాట్ ఈజ్ I3? వాట్ ఈజ్ I3? How many are there? What is the I? I3. Now you understand how to get the values of I and I3. If you want to get I3, first you have to get I. Without I, you won't get I3. So once you got I, in that group, higher charge will take higher value, lower charge will take lower value. Am I right? Always remember, IZ takes values from minus I to plus I. And which addition it is? మీ బొంద స్కేలార్ ఎడిషన్. కాంపోనెంట్ అంటే స్కేలార్. ఎక్స్ కాంపోనెంట్ స్కేలార్. అదే చెప్పాను కదా, ఐడిజే ఫౌండేషన్ తీసుకుంటే ఇట్లానే ఉంటుంది. కమా కాంపోనెంట్ ఈజ్ ఏ వెక్టర్, కాదు స్కేలార్. So whenever you are seeing the particle, you have to see what group it is, how many are there, and get I value. After getting I value, in that group, what kind of charge it is having? Higher charge, higher value, lower charge, lower value. But what is the formula for I3? Formula, if you want, I will give. Anybody knows? I3 equal to, or IZ equal to Q minus Q bar. What is that? Q minus Q bar. Q is the charge, Q bar is the average charge. Come on, be serious, be serious. Not that much easy while you are handling all the particles. Higher charge takes higher value, lower charge takes lower value. Come on, make it fast. By tomorrow, everyone must learn all these things. Otherwise, we can't proceed further. Now, if I say the particle, can you say its I and I3 values? Are you ready? Completed, huh? So, always remember, first we have to get I, otherwise we can't get I3. A single particle I0, 2 particles 1 by 2, 3 particles 1, 4 particles 3 by 2. And I and I3 exist only for hadrons. Now, everybody try once again. Now, I am giving you the particle. First you say I value and then you say I3 value. I will say I will say I3, then give the value. Are you ready? So, whenever first you are saying I value, you have to remember how many are there in the group. 1 is there, 2 are there, 3, 4, 5. That's it. Is it clear? Now, everybody say. Now, I will give you the particle, you please say its I value and after that I3 value. Are you ready? Ready, start. K minus I, I3, pi naught I, pi naught I, I3, cascade minus I, cascade anangalle 2 are there, 1 by 2 you have to get. Cascade minus I, I3, neutron I, I3, K plus I, I3. Next, sigma naught I, sigma naught I3. Next, cascade minus I, cascade. Cascade minus I3. Right. Proton I, I3. నెక్స్ట్ k మైనస్ ఐ చెప్పండి ముందు ఆకారాలు ఉన్నారు ఒక్కొక్కళ్ళు వాళ్ళకి అర్థం కాదులే పాప ప్రోటాన్ I3 నెక్స్ట్ k నాట్ I3 అసలు ఏం క్వశ్చన్ అడిగాను రెడీ the last one right listen we can't stop in the middle wait strangeness amma be careful by tomorrow everybody please learn seriously please learn okay 5 marks babu 5 plus 5 10 marks okay listen strangeness quantum number this is a s what is this strangeness listen actually we have amma listen carefully we have elementary particles. Elementary particles are generally classified into leptons as well as hadrons. And remember, leptons are always weakly interacting. Weak means W-E-A na? Weakly interacting. Hadrons are strongly interacting. This is by nature. All leptons must undergo through weak interaction while they are interacting. All hadrons must undergo strong interaction by their nature. But what happened? Some particles, some hyperons behaving like a strange particle. That means behaving strangely. Wait. But what happened? Some hadrons behaves strangely. What is that strange behavior? Let us see. I hope now you understand. All hadrons are not strange particles. Only few hadrons are behaving strangely. What are those hadrons? Amma, very important. What are those hadrons? Amma, hadrons means what? Mesons as well as baryon. So what are some hadrons? K mesons and K anti-mesons. I hope now you got it. K mesons means K plus and K naught. Anti-mesons K minus. Next, lambda naught, sigma group, cascade group, omega minus. All these are strange particles. All hadrons are not strange particle. Only these are strange particle. K mesons, means here sigma plus, sigma naught, sigma minus, cascade naught, cascade minus. Clear? Only these are strange particles and these are all called hyperons. Oh, sorry. This red color is not hyperons. This yellow colors are what? Hyperons. Not this. The meaning of hyperons is they are having a hypercharge called Y. This is a baryon plus strangeness. Baryon as well as strangeness. So that's why these are called hyperons. That's good. Okay, no problem, leave it. This is old theory, they call it as hyperons, that's it. So finally, some hadrons are behaving strangely. What are those particles? K mesons, K anti-mesons, lambda naught, sigma group, cascade group, omega minus. One more time I am asking, what are strange particles? Good. Now today just we are finding, we will discuss more clearly later. Now today we are finding a strangeness quantum number. Strangeness quantum number. I will discuss one, after that do it in the break time. And here we are introducing Gell-Mann and Nishijima formula. Gell-Mann and Nishijima. What is this? Listen. Actually, earlier first they have given like this. Charge of the particle Q equal to its I3, third component, plus B plus S by 2, where B plus S they have taken as a hypercharge. What is the hypercharge? Y. Y equal to B plus S. This is first they have given. What is the Gell-Mann Nishijima formula? Q equal to till now you know what is the charge, you know what is I3, you know what is a baryon number. What you don't know? That's why we will get strangeness from this formula. Say yes or no. Yes. What is the Gell-Mann Nishijima formula? Repeat. Q equal to I3 plus B plus S by 2. Later on, some people, they have modified this. The more general one, the modified one. The modified one is Q equal to I3 plus, the hypercharge is changed, B plus S plus T plus C plus T plus B by 2. Repeat. Q equal to I3 plus B plus S plus C plus T plus B. Baryon number, strangeness, C for charmness, topness, bottomness. Bottomness contain only bottom quark, top quark, charm quark, like that. So that is also added. This was the previous CSIR question, 5 marks. Which of the following represent Gell-Mann Nishijima formula if charmness is introduced? Say. చెప్పండి క్వశ్చన్ చదవరు అక్కడ క్లియర్గా charmness is introduced, then what is the Gell-Mann Nishijima formula? Right. I think no need to take this. Now take this one. I will explain only one, Babu. Everybody please see. Choose any one of your group, any one particle. Which one you want? Let us start with K mesons. I am taking K mesons, K plus and K naught. Remember, strangeness is the same for all the particles in the group. In a group, strangeness is the same. Now, take any one particle, your wish. Shall I round off K plus? What is its charge? Write the formula. Extra kelloddu. Write the formula and write properly. Charge plus 1. Wait. If you want I3, first get I. How many are there? I 1 by 2. I 1 by 2. But you want I3. Higher charge or lower charge? Is it a baryon? Very few people are saying. Is it a baryon? What it is? Baryon. Strangeness you are finding. Ante babu, nothing else. Bring 1 by 2 this side. 1 minus 1 by 2. S by 2. 2 gets. S is equal to strangeness of K mesons. Shall I take anti-mesons? What is the anti-meson? Anti-meson strangeness. You please try. Next, choose any other particle. Sigma. Na? Rest of the things like this, please take them up, because Strangeness is the same for all the particles in the group. Amma, write the formula. Q equal to any one particle round up? Sigma? Sigma minus. What is the charge? Say properly. What is the I3 for sigma minus? Few people only saying. Is it a baryon? ఎందుకు అంత డౌట్ చెప్తారు 1 plus s by 2. Bring minus 1 this side. Minus 1 minus 1. So that's why s plus 1 by 2 equal to. Then s is equal to. So what is the strangeness of sigma group? Like that, I request you, please check sigma strangeness for k mesons. You please check. Everybody must find all the things. S equal to lambda naught, s is equal to minus 1. Sigma, s is equal to minus 1. Cascade, s is equal to minus 2. Omega minus s is equal to minus 3. Okay, like this you have to get. I explained only one and sigma group. You have to do k anti-mesons, lambda naught, cascade group, omega minus, and try to remember k mesons strangeness, anti-mesons, lambda naught, sigma group, cascade group, omega minus, cascade group, sigma group, lambda naught, lambda naught to sigma group minus 1 and cascade group minus 2 and omega minus minus 3. Now you got a doubt. Ayya, sigma star group same. Sigma star group also same. I told you each and every character is the same except spin. That's why strangeness for sigma star group, cascade star group. That's it. Please practice, please complete all the things, remaining things find out. Or take a break and find out. I find only the 2 groups, rest of the groups you please find in the break time.